Good morning, afternoon, or evening. Today we're going to be looking at integration, our first day. And I guess what we're going to do here is we're going to be looking at the reverse rule for the power rule. So we're going to go from a derivative back to the original equation now. Before we were looking at, when we did derivatives, we had a rule for the power rule. Now we're going to go, what is the opposite of that rule? To get the antiderivative or integration or integral is what we'll call them next day probably. So that's what we're going to focus on today. Let me just get my timer up so I can see the time. Okay, and tomorrow will be some practice work with it. There's 10 question practice sheet that I'll give you. Today will just be video and some examples. I'm going to do, I think, 4 different kinds of examples here with using the antiderivative or integral rule with powers. We're going to go from second derivatives all the way back to original derivatives. We won't go into triple derivatives or anything like that, but we'll go into up to second derivatives. So we're going to do an example of, give you the formula, give you some basic examples first of all. Then we'll look at examples where we're dealing with speed, distance, and acceleration as they're related between derivatives, as we did in the last unit. We're going to go the other way now. And then we'll do a curve example, because we know that slope of a curve is a derivative. And then we'll do maybe a slope, a curve example with 2 points on it or something like that. So we'll do 4 different kinds. So let's start off by stating the antiderivative rule. So if you want if you have, let's do this in blue. If you have y prime equals, the derivative equals x to some power n. To get back to the original y, you simply add 1 to the n and divide by that power on the bottom, plus some constant that you might have. This is could be any number. So this is a constant. Okay? The integration constant, we call it later on. Okay, so this is our rule right here. Okay. Sometimes you can solve for this constant given some extra information. But just generally speaking, if we do some basic simple examples to start with. So let's say that find y if y prime equals 6x minus 7. Okay, so we're going to use this rule. So we're going to take the 6x, which is x to the 1, add a 1 on it. 1 plus 1 is 2, put that on the bottom. Minus, 7, if there's no x there, we add an x. And that's over 1, because we only added x to the power of 1. Plus c. So our y is equal to 3x squared minus 7x plus any number. Because if we do the derivative here, this would be 6x, no problem, minus 7. Perfect. And this constant could be any constant. Now we'd have to have some extra information about this to be able to solve for that. Let's do another one of these, some basic ones. Okay. So if you can't solve for it, you just leave it as C. Okay, so example 2, let's say that y prime equals 9x minus 3. Okay, so y prime, if we do antiderivative once, we'll get the y prime. So we'll go 9x, 1 plus 1 is 2 over 2 minus 3 plus constant. We'll call it C1 because we're going to have two constants. Okay, and then we'll have to do it again. So y will equal, okay, we're going to take 9 over 2. And then we're going to go x to the 3. And then we're going to divide that by 3 this time. And then this is going to be minus 3x oops, I forgot the x here, squared over 2, right? Because I forgot to put that x there. So that should have been an x there. That would make this, when you're doing the antiderivative again, an x. And then this would be plus c1 times an x plus c2. Okay, now we can simplify this. Okay, this would be 9 over 6. 9 over 6 is the same thing as 3 over 2. 3x cubed over 2. If we simplify that, and this would be minus 3x squared plus c1x plus c2. Okay, let's double check to make sure I did the right math here. 9 over 2x times a third would be 9 over 6. 9 over 6, we can go to 3 over 2. This one here, 3 over 2, no problem. X there, no problem. And we don't know what C1 and C2 are unless we know some information. So this would be our original equation for y. Okay, so sometimes you can do antiderivative twice. Okay, so those are basic. Now let's do one more. Let's do a more complex one here. Let's say we'll divide this like this. What if I had y prime equals 3x to the fourth minus 8x squared plus 7. Okay, so we got to do y. So I go 3x, 4 plus 1 is 5, over 4 plus 1, which is 5, minus 8x, 2 plus 1 is 3, over 3, plus 7x plus a constant. Okay, simplify this. Y would equal 3x to the fifth over 5 minus 8x cubed over 3 plus 7x plus c. Okay, so there's examples of doing the integration or the antiderivative rule. Okay, so there are a couple of questions. Let me just check my time to see where we are on time here. That's the first examples of doing basic examples. So I'm going to do 3 more examples. The next one I'm going to do is dealing with speed, distance, and time. So flip over the page here. Okay, example with distance, speed, and acceleration. Remember that if you take the derivative of s, you get velocity. If you take the double derivative of s, or distance, you get acceleration. If you take the derivative of velocity, you get acceleration. So we're going to go find the distance function s for acceleration equals negative 32 if the velocity is 30 when t is 1, and the distance is 70 when t is 2. So step 1 is to start with the acceleration and find velocity by doing the antiderivative. So take the antiderivative of a. Say a is some function of t, which will give us the velocity. Okay, if we take the antiderivative of this, so let's do the antiderivative of negative 32. So negative 32, and this is going to give us our velocity, or speed if you like. So how do you take the antiderivative of this? Well, you take put an x there, or in this case t, I guess, because we're dealing with time, sorry, because we got t1 and t2. Okay, so t plus a constant. That's it. Okay, now we can find out what the constant is by using this information right here and this information right here. Okay, the velocity is 30 when t is 1. So we're going to say velocity equals 30 when t is 1. Now we're going to calculate C1. So this would be 30 equals minus 32 plus C1. Add minus 32, add 32 to get rid of it, add 32. So we get 62 equals C1. So therefore, we have an expression of velocity. Velocity now is equal to minus 32t plus 62. Okay, so find the distance function, S. Well, we've got the velocity function. We have to do the antiderivative one more time to get this speed function. So to get the distance function, not the speed function, pardon me. So if we want the distance function, S, so we go antiderivative of velocity. Okay, so that's going to give us st. So st is going to equal the antiderivative of this. So we got to go minus 32 t to the 1 power. 1 plus 1 is 2 over 2 plus 62 t, add 1 over 1 plus c2. So st equals negative 16t squared plus 62t plus the constant, second constant. Okay, now we can use this information to find out what would the second constant be. So the distance is 70 when t is 2. So this is 2 squared plus 62 times 2 plus c2. Okay, so 70 equals, okay, this would be 4. 2 times 2 is 4 times 16. 4 times 16 is minus 64. And 2 times this would be 124 plus C2. So this would be 70 equals 60 plus C2. And if we do the math on that, subtract 60 from both sides, 10 equals C2. Therefore, now we have our final equation that we need. So therefore, ST would equal negative 16t squared plus 32t, or sorry, not 32, 62t plus C2, which was 10. And there's our distance equation. And that's how you would do those. Okay, so remembering that going from acceleration, taking the antiderivative gives you velocity, and taking the antiderivative of velocity gives you distance. Okay, now we'll do a question where, in our third example, we'll do one where you're given 2 points on a curve, and the second derivative, we'll say. That's my next example here. Okay, so let's flip ahead. Okay, find the original curve equation given, not give, given the second derivative and 2 points. So here's an example. Given that y prime prime is 12x plus 10, and that a at 0, 2 and B at 1, 1 are points on the curve. Find y. So what we're going to have to do is we're going to have to do antiderivative twice, and then we're going to have to plug in these points to find C1 and C2. Okay, so first of all, we're going to do antiderivative to get the y prime. So antiderivative of this is going to equal 12x to the power of 1 plus 1, which is 2, over 2, plus 10. Okay, and there's no x there, so we have to add 1. That'll be over 1 plus a constant. Now we can't put any of these points in yet. We'll call it C1, because this is a point on the graph, not a point on the derivative. It's a point on y. So this would be a slope equation. So if you were given slope, you could plug it in. And we'll do our last example like that. So we can simplify y prime to 6x squared plus 10x plus C1. So now we have to do another antiderivative to get the y, and then we can plug in these 2 points one at a time to find the C1 and C2. So y equals antiderivative of y prime is y. So we do antiderivative. 6, okay, 2 plus 1 is 3, so over 3, plus 10x, 1 plus 1 is 2 over 2, plus C1x plus C2. Okay, we can simplify this. Y equals 2x cubed plus 5x squared plus C1x plus C2. Now, we notice that we have a 0 here, so if we can put a 0 in for x, we're going to get 2 for y. So that's going to allow us to solve for C2. So we're going to plug in a first. So 2 equals 2 times 0 cubed plus 5 times 0 squared plus C1 times 0 plus C2. So this is 2 equals 0 plus 0 plus 0 plus C2. So C2 is equal to 2. So we've got this one figured out. And then we're going to plug in 1, 1 now to figure out the second equation. Okay, so plug into this equation again. Now that we now have y equals 2x cubed plus 5x squared plus C1x plus 2, because we knew what C2 is. Now we can plug in 1, 1. So y equals 1, x equals 1. Okay, like this. Solve for C1 now. Okay, so we've got 1 equals 2 plus 5 plus C1 plus 2. So 1 equals 7, 8, 9 plus C1. So subtract 9, we get negative 8 equals C1. So now our total equation, therefore our final answer, y equals 2x squared plus 2x cubed, plus 5x squared. Now we put minus 8 in there for C1, x, and 2 for C2. And that's how you would do those kinds of questions. Okay, one more example for today. We're sitting at about 20 minutes. And then you can, if you want, you can probably start on your practice, but I'm going to leave tomorrow for practice work. There's 10 questions. So our last question is kind of like what I allude to in the last one. What happens if I give you an equation of a derivative, second derivative again, but instead of giving you 2 points, I give you a slope at a point. So let's do that one. Here is my final example for today. Okay, it says, given a point and a slope with the second derivative, say y prime prime is 6x minus 4. Find the equation of the curve if at point 1, 2, the slope is equal to 4. That's a 4. Okay, so step 1 is to find the slope is going to equal y prime. So let's get the y prime. So y prime is going to be the antiderivative of this. So 6x, add 1 to it, so squared over to 2 minus 4x plus c1. Okay, now we're going to solve this particular equation. We're going to first we'll simplify it down to 3x squared minus 4x plus c1. Okay, now to find c1, we're going to put the slope in at x equal 1. Slope is 4 at x equal 1. What do we get? 4 equals 3 minus 4 plus c1. 4 equals minus 1 plus c1. c1 equals 5. So we've got a y prime now that is equal to this equation. 3x squared minus 4x, is that minus 5 or plus 5? Plus 5. Okay, so that is our halfway there. Now we can use this point and do the antiderivative to get y, and then plug this point in to find the other constant. Like this. You go, okay, y is going to be the antiderivative of this up here. So this is now going to be 3x, okay, 2 plus 1 is 3 over 3, minus 4x squared over 2 plus 5x plus c2. Okay, we can simplify. Y equals x cubed minus 2x squared plus 5x plus c2. Now it's give us the point 1, x is 1, y is 2. So now it's on the curve, so we can say 2 equals 1 cubed minus 2 times 1 squared plus 5 times 1 plus c2. Let's see what we get. Okay, we got 2 here. 1 minus 2 plus 5 plus c2. 2 equals, what's this? Minus 1 plus 5 is 4 plus c2. Subtract 4. Minus 2 equals c2. So now we can state our final value for the y curve. Y would then equal x cubed minus 2x squared plus 5x minus 2. Okay. Now, I am going to give you a work period tomorrow, but I'm going to show you what the questions look like. You could get started today if you want, because we are only about 24 minutes in, so it'll be about a 25-minute video here. So if I were to pop the practice up here, okay, we'll bring it over. Okay, and here's our practice, okay? This is derivative, find y. Here's g prime, find g. Okay, a distance 1, another distance 1. Okay, this one here, acceleration 1, distance function again, another distance 1. Oh, here's a point 1. Here's another one, and here's another one with the slope of and the curve. And then the solutions are right here underneath it. So you can work on that today and tomorrow. I'll leave tomorrow's class as practice. Should only take you about 20 minutes to do, so nice and short. And then on day 3, we'll get into the integration symbol, and we'll start calling the antiderivative integration, and we'll come up with some more types of integration that we will do. Okay, so that's next day. If you want to get a jump on your practice, you can go ahead and do it. All right, so good luck.